Welcome to Cassini Huygens by Jackson Shibley and Jacob Reel. Cassini Huygens had several purposes during its long mission. It was to determine the three-dimensional structure and dynamic behavior of the rings of Saturn. It was to determine the composition of the satellite surfaces and geological history of each of Saturn's satellites. It was also intended to determine the nature and origin of the odd dark material on Laptor's leading hemisphere. It was meant to measure the three-dimensional structure and dynamic behavior of the magnetosphere. It was meant to study the dynamic behavior of Saturn's atmosphere at cloud level. It was also intended to study the time variability of Titan's clouds and hazes. And it was going to break a world record, landing the Huygens probe on Titan's surface, it now being the furthest away we have ever landed something. Cassini-Huygens was a flagship-class robotic spacecraft developed in the late 1980s and early 1990s. Cassini was intended to provide a modern probe to continue the legacy of Pioneer 11 and the two Voyagers that both previously visited Saturn. Cassini was a heavily modified Mariner Mark II design. Mariner Mark II was NASA's planned family of unmanned spacecraft for the exploration of the outer solar system between 1980 to the year 2010. This project was mothballed after the collapse of the Soviet Union. However, a few major designs were endorsed by the famous astronaut Sally Ride and continued their development. Two of the surviving concepts were combined to create the Cassini-Huygens program. The European Space Agency, ESA, and the Italian Space Agency, ASI, were to design and create the Huygens probe, intended to land on Titan, while NASA was going to modify their existing Mariner Mark II design to become the now Cassini space probe. On October 15, 1997, Cassini was launched from Cape Canaveral Air Force Base. On April 26th, it did a Venus flyby to gain speed. In 1999, it began its second flyby of Venus, this slingshotted towards Earth, where it did another flyby on August 18th. It begins on December 30th, 2000. It begins a 6-month swing by Jupiter and collaborates with Galileo to study the Jovian system. On June 30th, 2004, it finally arrives at Saturn, after a very, very long time of travel. On December 13th, its first flyby of Titan and Dione. On December 24th, it releases the Huygens probe and lands on Titan. The primary mission was completed in June of 2008. It was then extended to become the Cassini Equinox mission, and after that was extended to become the Cassini Solstice mission. In September of 2017, Cassini began its great end, called the Grand Finale. In this, it would do a series of very dangerous and possibly destructive dives through Saturn's rings and eventually into the surface. This would stop it from damaging any of the planets and the potentially life-harboring oceans that they had beneath them, meanwhile while gaining unprecedented knowledge from these risky scientific experiments. There were several aspects that determined the cost of Cassini-Huygens program. The total cost of the scientific exploration mission was about $3.26 billion US, including the $1.4 billion for pre-launch development, $704 million for mission operations, $54 million for tracking, and $422 million for the Titan IV-B recycled intercontinental ballistic missile launch vehicle. The United States contributed $2.6 billion, 80%, ESA $500 million, 15%, and ASI $160 million, 5%. The Cassini orbiter had many, many instruments on board it. It was essentially an entire engine with a nuclear-powered plant and a whole bunch of scientific instruments strapped to it. This included the optical remote sensing system. This is located on the bottom right side of Cassini. It was also meant to study field particles and waves, with a plasma spectrometer, cosmic dust analyzer, ion and neutral gas spectrometer, magnometer, which is that very large beam that you see going out of it, and magnometer imaging instrument. Its massive radio antenna could also act as a radio telescope, pointing towards Saturn and seeing what kind of FM, AM, and other types of high-frequency radio waves it emitted. It also contained a small radar science system on board, just for simple distance ranging. Cassini was powered by 3 general-purpose heat-source radioisotope thermoelectric generators, GPHS-RTG, a type of nuclear reactor that directly converts heat from decay of about 32.7 kilograms of plutonium-238 to generate direct current electricity via thermoelectrics. Think of these as heat-based solar panels. The RTGs on the Cassini mission have the same design of those used on the New Horizons probe, Galileo, and Ulysses space probes. These were designed to have very long operational lifetimes and only decayed slightly by the end of Cassini's mission. In fact, one of the spare RTGs assembled for the Cassini mission was used to power the New Horizons mission to Pluto and the Kuiper Belt. The Huygens lander contained many instruments just for determining Titan's composition and attributes. One issue that they had is that it was known that Titan had liquid rivers of methane, so it had to be able to land in both liquid and solid land. This made it quite difficult for them to engineer. In total, they engineered the Huygens atmospheric instrument, the Doppler wind experiment, which uses an ultra-stable oscillator to do something similar to an earthquake in the wind, which then it can measure how cold it was with extreme accuracy. Descent imager, which was essentially a high-powered camera, gas chromatograph mass spectrometer. This was designed to determine the composition of Titan's atmosphere, aerosol collector and pyrolyzer. This drew in the aerosol particles from the atmosphere and then decayed them to seeing if they could process any kind of organic life. And the surface science package. This was the standard package contained on many of NASA's standard landing missions. Cassini was powered by batteries that ran for about 90 minutes after being landed on the surface. Before that, it would drain off a low power mode and only have to use Cassini's main 3 nuclear reactors. Throughout its 20 years of operation, Cassini made 8 massive discoveries. First of all, it landed on Titan and studied the moon's prebiotic chemistry from orbit. Second, it studied the jets and ocean of Enceladus and how it might harbor life. 3, it studied how Saturn's rings change over time. 4, it proved the once theorized hexagonal storm of Saturn's poles. 5, it investigated Laptus and its abnormalities, finally figuring out what caused that great darkness. 6, it discovered the temperature abnormalities of Tethys and Mimas, and discovery of polypropylene on Titan. This is a building block for many parts of life, and it discovered several new moons of Saturn hidden among the rings.
Who were Cassini and Huygens? First of all, we'll start with Cassini. Giovanni Cassini was an Italian astronomer who made a lot of firsts for the world of astronomy. He was born in June 8th, 1625, and died on September 14th, 1712. He spent 2 years being educated at Vallabona, Fren Fructuoso, and Jesuit College at Genoa, where he studied under Cassini. In his youth, he showed a keen interest in math, astrology, and poetry, and apparently he was an expert in hydraulics and engineering. Cassini did a lot of stuff, so we'll just go through a big list of them. Cassini observed and published first surface markings on Mars, determined the rotation periods of Mars and Jupiter, discovered 4 satellites of Saturn, Iphitus, Rhea, Phaeus, and Dione. In addition, he discovered the Cassini division of rings of Saturn in 1675. Around 1690, Cassini was the first to observe differential rotation within Jupiter's atmosphere. Cassini was also first to make successful measurements of longitude by a method suggested by Galileo. In 1683, Cassini presented the correct explanation of the phenomenon of zodiacal light. He was also partnered with Jean Richer, and he made 2 observations with him. One was about Mars. By calculating the parallax, they found the distance from Earth to Mars, and this is the first time they could ever see the dimensions of the atmosphere. But by far his most important one is when he discovered the 4 satellites. He also had a legacy, so after he died, his 4 kids took over, finishing his work, such as the topographic map of France and the dictator of the Paris Observatory, which he was also part of. He was picked for this mission because the mission was all about the mission worked with the Italians, and he also did a lot of stuff to do with Jupiter, so they named it after him. Now we move on to Huygens. Christian Huygens was a Dutch physicist, mathematician, astronomer, and inventor who was born on April 4th, 1629 and died July 8th, 1695. Huygens was one of the leading scientists at the time. His education was he studied at the University of London from May 1645 to March 1647 and studied in March 1645 at Orange College. In the field of optics, he was best known for his wave theory of light. As an inventor, he improved the design of the telescope with the invention of the Huygens eyepiece and made the most accurate clock for 300 years. Huygens made groundbreaking contributions in optics and mechanics, but what really made him special was in astronomy, he was chiefly known for his studies of the rings of Saturn and the discovery of its moon, which was named Titan. In 1655, Huygens proposed that the sun was surrounded by a solid ring, a thin, flat ring where nothing was touching. Saturn. He was a good pick for this mission. His name was picked for this mission because he was the first to discover Saturn moons, and the mission has a lot to do with Saturn's moons, and especially Titan, the biggest one, which he discovered.